Hi everyone, my name is Maureen Gamon and this is my course project in MIS6314. Scaling Networks. This is the introduction of scaling networks. Businesses rely on the network infrastructure to provide mission critical services. Network outages can result in lost revenue and lost customers. Network designers must design and build an enterprise network that is scalable and highly available. Scaling computer networks. Businesses can grow along with their needs in terms of users' uptime and speed. Enterprise networks needs enterprise hardware. A computer network is designed to accommodate the need for growth is called scalable. It is composed of three layers, bottom to top: access, distribution, and core. Each layer has a specific function. Hierarchical network design. Access layer. Access layer is in charge of providing a connection to the final users in a local network. The, di- the distribution layer forwards traffic from or to different local networks. And the core layer is a high-speed backbone between distribution blocks. That is networks that are geographically dispersed. And this is the hierarchical network design model. Enterprise Campus. Enterprise Campus is a server farm and data center module. This section provides high-speed connectivity and protection for servers. It is critical to provide redundancy, fault tolerance, and security as well. The network management systems monitor performance by monitoring device and network availability. Services module. This section provides access to all services such as IP, telephony services, wireless controller services, and unified services. Enterprise Edge composed of Internet, VPN, one and VPN and one modules connecting the enterprise with the service provider's network. This said module extends the enterprise services to remote sites and enables the enterprise to use internet and partner resources. It gives QoS policy reinforcement, service levels, and security. Service Provider Edge provides internet, public switch, telephone network, and WAN services. All data that enters or exits the enterprise composite network model passes through an edge device. This is the area where all packets can be examined and decision made whether the packet should be allowed on the enterprise network. Intrusion detection systems. An intrusion prevention system can also be configured at the enterprise edge to protect against malicious activity. Cisco Enterprise Architecture. Enterprise Campus can have additional submodules such as server farm module, data center module, and service module. These submodules provided network monitoring and unified control of services such as wireless controlling or telephony services. The Enterprise Edge includes modules that connect the enterprise to remote sources through the service provider network, internet connectivity, VPN tunnels, and WAN. The service provider edge provides services through a service provider such as internet connection and phone lines. Each of these services has a corresponding edge device in the enterprise edge that examines all packet and decides whether it should be allowed on the enterprise network. Failure domains. A failure domain is the area of the network that is impacted by a problem or failure. The impact of failure domain is determined by the functionality provided by faulty device. If in a case problem occurs, smaller failure domains reduce the impact of the problem to the whole network, and it simplify repair and thus decrease downtime. This 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 is the failure domains model. Increasing bandwidth. Bandwidth demand continues to grow as users increasingly access video content and migrate to IP phones. An Ether channel implementation can add more bandwidth capacity to a connection. Implementing Ether channel. Some links between access and distribution switches might need to process a greater amount of traffic than other links. As traffic from multiple links converges into a single outgoing link, it is possible for that link to become bottleneck. Using link aggregation allows an administrator to increase the amount of bandwidth between devices by creating one logical link made up of several physical links. These are the implementing Ether channel model. Ether channel is a multiple traffic links between access and distribution switches will need to converge in a single outgoing link that could become a bottleneck. Wireless connectivity is a crucial in expanding a network because it increases flexibility without excessive cost. Implementing wireless connectivity required at the very minimum a wireless NIC for end devices, access point, or wireless router. These are the things to be considered in wireless implementation. These are the types devices: coverage, interference, security, speed and protocols. Fine-tuning routing protocols. Routing protocol is a configuration is usually rather straightforward through to take full advantage of a protocol's feature set. It is advantageous to adjust the configuration. Managing the routed network. Enterprise networks and ISPs often use more advanced protocols such as link state protocols because of their hierarchical design and ability to scale for large networks. These are the managing routed network. Link state routing protocols such as open shortest path first. Cisco has five categories of enterprise switches: campus LAN switches, cloud managed switches, data center switches, service provider switches, virtual networking switches, and these are the enterprise switches come in a several form factor: fixed or modular configuration, stackable and or non-stackable. These are the five categories of switches for enterprise networks. campus LAN switches, cloud management, cloud managed switches, data center switches, service provider switches, virtual networking. Basic router show commands. The basic router configuration includes the host name for identification, password for security, assignment of IP address to interfaces for connectivity, and basic routing. This video it shows the commands of basic router such as show IP protocols, show IP route, show IP, show interfaces. Show IP interfaces. LAN redundancy. The network redundancy assures network reliability by using multiple physical links between devices, redundant paths. A network can continue to operate when a single link or port has failed. Purpose of spanning tree. STP provides the mechanism to have redundant links at layer 2 while avoiding the potential for loops and MAC address database instability. These are the three concepts, the spanning tree concepts. Multiple cabled paths between switches provide physical redundancy in a switch network, provides improved improves the reliability and availability of the network, enable users to access network resources if some path goes down. Redundancy. Redundancy is an important part of hierarchical design for preventing disruption of network services to users. STP operation. It uses the concept of a root bridge, port roles, and path cost to calculate which links to use in a redundant topology. It is spanning tree algorithm. It ensures that there is only one logical path between all destinations on the network by intentionally blocking redundant paths that could cause a loop. Spanning tree algorithm port roles uses the spanning tree algorithm to determine which switch ports on a network must be put in a blocking state to prevent loops from occurring. These are the root bridge reference point for all spanning tree calculations to determine which redundant paths to block. Path cost. The path information to determine by summing up the individual port cost along the path from the destination to the root bridge. Each destination is actually a switch port. The bridge ID is used to determine the root bridge on a network. The bridge ID field of a BPDU frame contains three separate fields: bridge priority, extended system, and MAC address. Bridge priority is a configurable value that can be used to influence which switch becomes the root bridge. The switch with the lowest priority, which implies the lowest BID, becomes the root bridge because a lower priority value takes precedence. The varieties of spanning tree protocols. STP has evolved into several different versions since the original specification. These are the list of spanning tree protocols: STP and PVST plus 802.1D-2004, Rapid Spanning Tree Protocol, and Rapid PVST plus, Multiple Spanning Tree Protocol. These are the characteristics of spanning tree protocols. STP is STP spanning tree instance for the entire bridge network regardless of the number of VLANs. PVST Plus Cisco enhancement of STP that provides a separate instance of the Cisco implementation of 802.1D for each VLAN that is configured in the network. RSTP, Rapid PVST Plus, MSTP, and MST. Edge ports. An RSTP edge port is a switch port that is never intended to be connected to another switch device. Link types. The link type provides a categorization for each port participating in RSTP by using the duplex mode on the port. One way to prevent a single point of failure at the default gateway is to implement a virtual router. These are the router redundancy. Link aggregation. Link aggregation is the ability to create one logical link using multiple physical links between two devices. This provides load sharing among the physical links. These are the advantages of Ethernet channel. These are the Ether channel operation, implementation restrictions, and port aggregation protocol. PAGP or port aggregation protocol is when an Ether channel link is configured using PAGP or port aggregation protocol packets are sent between Ether channel capable ports to negotiate the forming of a channel. When a port aggregation protocol identifies matched Ethernet links, it groups the links into a Ether channel. The Ether channel is then added to the spanning tree as a single port. Link Aggregation Control Protocol or LASP. LASP is a part of an IEEE specification that allows several physical ports to be bundled to form a single logical channel. Verifying and troubleshooting Ether channel. These are the show Ether channel summary command. This is the show Ether channel port channel command. And again, this is my course project in MIS6314. I'm Maureen Gammon and thank you for listening.